Section 12.1 is what linear regression inference is about, using a sample regression line to estimate the population regression line. So that's sort of in a nutshell what it's about. And we can do that with confidence intervals and hypothesis tests using a sample regression line. To either estimate or test a claim. Estimate or test a claim about the population regression line. About the true population regression line. True population regression line. Regression line. Okay, so there are five conditions for these tests or confidence intervals that you have to check. There are 5 of them on this, and there's a little mnemonic to help remember them called LINER, L-I-N-E-R. So the first one is for the L. Give me an L. Is the linear part, which is that the relationship between x and y is linear. So the relationship between x and y is linear, and if you did print your reading notes, because they have been up there, one of the questions is to summarize these conditions. The relationship between x and y is linear. Okay, number 2 is for the I. I stands for independent. So that's nothing that we're already used to that. The individual observations are independent. Independent. The third condition is, this is normal, but what do we need to be normal? And normal is the residuals. And the residuals are the distance of each measurement from the regression line is the residual. So if it's above the regression line, it's positive residual. If it's below, it's negative. So we need the residuals, and you'll see in the example that follows, we need the residuals to follow a normal distribution. Follow a normal distribution, and there's a couple ways of checking that. We can do a histogram or a normal probability plot, and I'll show you some of both. Distribution. Okay, and condition 4, this we haven't seen before, E for equal variance. Equal variance, and that means that for any x value, the y's around it vary about the same. Or another way of saying that is the standard deviation of y is the same for all x. I'll show you a picture in the example. So equal, it varies equally. The standard deviation is a measure of how much variance there is. So the standard deviation of y is same for each x, roughly the same. And then the last condition is R for random. Okay, so the data is produced from a randomized experiment. So I'll just write random there. Okay, so those are our 5 conditions, and now our formulas for confidence intervals or testing a claim are these. So when we do a confidence interval, which you'll do today, and then on Monday we'll do tests. So the interval, you're going to do the t interval like we did for means. T interval, and it's on the slope. That's what we care about. How much change is there in y for every unit of x. So you'll do t interval for the slope. Beta is the population slope. For the slope beta of the population regression line. Population regression line. And the formula is this. It's very simple. The sample slope, b, plus or minus T star, which is exactly the same as what you're used to. The way you find it is the same, times the standard error of the slope. In the video they wrote it as S sub b. In the book they use SE sub b, standard error of the slope, or standard deviation of the slope. So in this today, you'll just look at the computer generated output and you'll find that number and you'll plug it in. That's how you'll do it today. To find T star, when you use the degrees of freedom, make them n minus 2, sample size minus 2 to find T star. You'd say inverse T, just like you're used to. B is, let me label these, B is the sample slope, which will be given. And let me just write out in words what this means. That's how much the slope of the sample regression line typically varies from the population regression line. The standard error of the slope. So how much the slope of the sample, there's no shorter way of writing this, how much the slope of the sample regression line typically varies. It's a way of describing standard deviation. Typically varies from the population regression line. Pop regression line. So that's the formula there, and I'll show you how to use it in the example today. And then on Monday, we'll use this one. We won't worry about it today. For doing a hypothesis test, here's the formula for that, and then you'll have all the formulas in one place for this section. The test statistic T is equal to the sample slope minus the hypothesized slope for the population. So I'm gonna describe that. This is like what you're used to. It's the one that you state in H0, hypothesized slope stated in H0. So like it's gonna be 0. So like that. Over the standard error of the slope, which is the same as it was before. So that's everything for 12.1.